So today I'm going to talk about Matryoshka embeddings models, and actually this is like state of art in embeddings and natural language processing, and it is like a part of bigger project that I am working on, which serves the Arabic language specifically. So today I am going to give like a brief introduction to Matryoshka embeddings models, and I will talk more about what I am going to do in the future. So basically, we need to understand embeddings, and as we know, it is very important step, like in natural language processing in general, and more specific, we are using this in more downstream tasks like retrieval or clustering, classification, and also like it is very important, like in large language models, and it is very simple idea. Like we need like a language to make these machines understand, and yeah, we are doing this by using the embeddings. So it is a like numerical representation of complex objects like text, images, audio. But today we are focusing on text. So basically, we have the text here, different text. Yeah, every text has its own embedding or its own vector representation. So actually, these embeddings are fixed in size. So we having like it is dimension fixed, and it allows for computing the similarity of complex objects. So if we have two sentences and we want to know how close they are to each other, we are using something called cosine similarity, and we are computing the cosine similarity for these embeddings, giving or resulting in the cosine similarity as we can see here. So similarity is determined by comparing these respective embeddings. Uh, yeah, so we are using embeddings in a recommendation system, which is serves like a backbone. Retrieval is one of the popular use of embeddings, like in retrieval augmented generation. So we need to convert the whole text that we have into embeddings and store it in the vector database. And we have like outlier detection, similarity search, paraphrase detection, clustering, and much more. Okay, so what about Matryoshka embeddings? Uh, so this is like a higher output dimension. It is a state-of-the-art text embedding models. We produce the embeddings with higher output dimensions. So each input text is represented now not in only one vector, no, in more values. So we have higher dimensions to improve the performance, but increasing the dimensions for each text that also decrease the efficiency in downstream tasks if we have the increased dimensions. So if we're representing each of the text, each of sentences in fixed size and increased dimension, we are decreasing the efficiency. And this is the inspiration actually by the paper that come up with the idea of the Matryoshka embeddings, where the solution is to create embeddings model with embeddings that could be reasonably shrunk. And through that, we aim to maintain more performance and while improving, of course, the efficiency. So yeah, this is the Matryoshka embeddings. Like we have one sentence, then we result in one dimension, and we do like the truncations step to have multiple dimensions of or multiple embeddings for the same sentence. Uh, for example, resulting in 512, then 256, then 128, then 64. We might have also 32. So these Matryoshka embeddings models are trained such that these small truncated embeddings would still be useful. So in short, we are creating or producing through Matryoshka embeddings useful embeddings. So this is why we call it Matryoshka dolls, or yeah, this name, which is also known as Russian nesting dolls, as we can see now. So the concept is inspired by the Matryoshka dolls, as we can see here, which is we store more information, more important information in areal dimensions, and we store less important information in later dimensions. So we allow truncation on the original large embeddings and then retains enough information to perform one on downstream tasks. So as we can see now, like we have the sentence that computes the Matryoshka embedding, and we have one that now we can see now split it into this by tourniqueting, and we can use whatever dimensionally we want, and we can perform more like processing or to perform other tasks. So yeah, this is the idea of Matryoshka dolls, and actually it is important in like what we call it like shortlisting and re-ranking. So we are shrink the embeddings to smaller size to do like efficient processing. As we know, if we have one fixed increased dimensions, we have like for the retrieval, we need more time to retrieve. We need more storage to store these embeddings. So yeah, these by these let's say disadvantages, we come up with Matryoshka embedding models to overcome these, and also we are still able to use the full dimensionally in our preprocessing if we want. So it's like a trade-offs between the scalability of the model, the processing, and the performance. So we adjust the embedding solution according to desired storage cost. Then we balance between processing speed and performance and optimize performance based on our available resources. So how does Matryoshka model is trained? So the Matryoshka representation learning can be used with almost all embeddings training frameworks we know. Standard training steps. So we produce embeddings for the training batch, and we use like a specific custom Matryoshka loss, we call it loss function, to create the loss value representing the quality of the embeddings, and the optimizer adjusts these model weights to reduce the loss value. So this is the steps. We like producing the embeddings for the training batch. We use the loss function. We define what dimensionalities we want for our Matryoshka models. For example, if we have a base model, a base embedding model with this dimension, we can split it on this, then 512, then 256, 128, 64, we might need 32, and we calculate then the loss values of each of the dimensionals. We sum these loss values to get the final loss value, and of course the optimizer will adjust the model weights to reduce the combined loss value. Okay, so this is basically how our Matryoshka model is trained, and for simplicity we are using sentence transformer. As we know, sentence transformer, big framework that contains thousands and more than thousands of embeddings models, so we can load whatever we want, and we train this model using the Matryoshka loss to perform on different Matryoshka dimensionals as we have seen. So yeah, we apply the same loss function to full size and to created embeddings, and we sum losses for all dimensions optionally with the weights. So in practice, how to use it? So yes, we obtain the embeddings the same way with the normal embedding model, and then optionally we can truncate these embeddings into smaller dimensionality as we have seen. We can do that like the normalization steps for the truncated embeddings, or we can like do post truncation in case we want to use for specific tasks, or like we are doing like small embeddings in vector database. This is in retrieval, for example, and processing smaller embeddings could be faster, and of course improving our RAG system, for example, as a task. In sentence transformer, for example, here I am just giving the dimensions I want, then I am loading here the model that I want. I am giving like 3 text sentences, and I can calculate the shape, and also then using the cosine similarity, I can know the similarities between these 3 models. So this is by using the sentence transformer package. So yeah, loading the model, and then we can choose our Matryoshka dimension, and we can perform this inference. This is that's it. I think for Matryoshka models is very simple idea. If you are interested more, you can visit this paper, the original paper. It gives like more details about the training, the inference, everything about the Matryoshka embeddings, and it shows like good performance, improved performance for different dimensionalities actually. And that's it for this part. What I am going to explain next part is fine-tuning these Matryoshka models for our Arabic sentence similarities. So it is ready. If you can visit my Hugging Face, and you can see different Arabic Matryoshka embeddings models fine-tuned on base models like Marbert, Arabert, or the Labas, or different, uh, MPNet base. And also you can see different data sets that are translated by me into Arabic, so I can use it later. So this is will be in next part. I am going to explain the data sets and also the models that I have trained, and we're gonna see like practical examples on how we can do like the similarities and how we can get everything as inference. So yeah, that's it. Hope you find this is useful, and thank you.